aquap2.
The light can stay like this. Thank you. Like this, it's okay. Oh, no, this. Good afternoon, everyone. Thank you very much, Sensei, for the kind introduction. Wow, where to start? So good to be together with you. Thank you very much for inviting us and giving us the opportunity to be here with such a wonderful people. It's so good to come back to Japan. To make the story short, so it will be an interactive course. Everyone is very welcome to join us and install our software with Mr. Pollner, Dr. Pollner, with Bernhard. We have been developing this aquap2 package. It's multivariate data analysis framework with a focus on aquaphotomics techniques, to be correct with the title. I think we have a quite challenging task for this 1 hour, because our mission is to prove to Paulo this software is not much more difficult than the solo what we have just seen. Okay, so we will try to do our best to cover everything important in this 1 hour. And I don't know who is interested to install the softwares and who needs help for that. Everyone who wants to join has both softwares installed, our project and our studio.
So who would like to actively take part, actively follow us for the hands-on introduction?
Hands up, please. Hands up, please.
Who wants to try it out? Okay. All of you who have your hands raised now, do you have our studio and R installed on your machine? Yes. Who has not installed our studio on their machine? Everybody has. Okay, this is good. Now then we can, but we don't have a picture. See something? We have a problem that we don't see anything.
I can talk without picture, as you can see.
Should we reconnect the HDMI maybe?
Okay, just to save time, so then I will dictate. Please go to https://github.com/bpollner/aquap2. github.com/
Double L, yeah?
Yeah, BPOLL.
GitHub.com. GitHub.com/BPOLLNER. Yes, that is my wonderful face. Then you go to aquap2. Go to aquap2 there. Read the README and do as it says on the README.
Okay, shall we try with the VGI?
Okay, do you have a VGA?
Nothing? No, but it's at HDMI. Oh, okay. So, what's wrong? It's good. It's good. I zoomed in. So this is the slide we should see. This is the website.
Okay. So all of you who want to. Thank you. Thank you. Good. Thank you, Alexander. So all of you who want to actively take part, you have all installed R first. Then you have installed R Studio. Then you go please to this website, and as Zoltan points out, follow the instructions on this README in R Studio. So we have some picture problems, that is not amusing. So you are at this website, at the repository, where it says in the README, install DevTools, and you paste what you see in the website into the R Studio. You first install the DevTools, and then when it says install packages DevTools, you copy that and paste it into R Studio. That's what you do first. Once this is done,
I'm doing together with you if someone is not much experienced with that. So
who was able so far to install the DevTools? Okay, Everin, over there.
just
okay.
copy paste from here to here. Okay.
Who is already at the lines the DevTool installs for aquap2? Who is doing that already? Kurt, okay, you have it. It's good. So, who has problems installing the DevTools? Okay, over there, for example, Bastian. GitHub.com, first GitHub.com.
Anyone has problem, hands up please, so we can try to help.
Okay, something over here. So you all have R Studio, you say, so. Okay. Zoltan, could you again please put on the website the address of the GitHub website? We need that. Please, everybody who has problems finding the GitHub, look now out on the slide, github.com. Go type in the address bar of your browser, please type in the link you see now on the slide. Yes. Everybody please now look to the slide. Type in this. It is enough if you type github.com, and then as you see it, and then you will there scroll down, you will find a README, and please do exactly as it says on this README. So who has not yet reached this GitHub repository? Okay, over there. Yeah, scroll down. Scroll down, okay. So install packages, copy that, paste into RStudio. If this is done, then you go there. Then you do. Open better RStudio, it's easier to do. Better open. If you use our RStudio, it's basically the same, but for beginners, we recommend to use RStudio because it's, for some reasons, more convenient. So this is just R, this is not RStudio. You have RStudio. No, this is just R. Okay, there's a difference. We have the download here. Quit R again. Put this in and drag all the materials. You need to have, it's recommended to really use RStudio and not directly R, it's just easier. So who thinks he or she might not have RStudio installed, because we have this case, okay? Okay, you're the demo data. If you're here, then go ahead. Download zip. And then we can say download the zip and then see what it says here. Okay, RStudio. We still had an RStudio problem here. Okay, so quit R, install RStudio, and then do what we had in RStudio. Okay. Who has problems? Let me over there, please. Yeah. Okay, so this is R and not R. This is R and not RStudio. Yes, you have to quit that. No, don't say. Just close it. And we don't need to save it. Okay. You need RStudio. No, this is R. RStudio, if you don't have that.
I just wanted to show you how this That's my source code. That's different than your code. Yeah.
Okay.
The slash drive. Copy the file. Save it. Describe one adequate. Do it again. One of them is mine. That's it, sensitive layer. Anyone.
Yeah. So, has anybody already successfully installed the aquap2 package? Okay, over there, that's nice. Wonderful. Pretty good. Okay. And then launch RStudio. Okay, who has problems? Who has problems to do the GitHub install of aquap2? Over here, okay. So 1 second. Alexander, yes. No error. Okay. So you used RStudio before?
Yes, I used them.
Okay, of course, I understand. Try to manually reinstall Crayon. Try to go to in the RStudio, go to packages, install, and then Crayon.
How do you do this?
Back up here.
Crayon. See what happens.
Maybe because it's me.
Okay, we'll learn from before. Better? Okay, do the same with error command check. Let's see, check and see. And then you work manually through the errors until it goes away, and then it's very unpredictable. Okay, the GitHub install from, 1 second, we were here before. Okay. Yeah. Zip File download. Achso, ja, dann hast du das XDS-File schon rüber kopiert, wie ich angeleitet habe. Sorry. Das hast du schon rüber kopiert? Ja. Ja, aber das hast du schon diese auf der... Okay, liest es genau. Okay, dann geh hierher. Du hast den Zip schon downgeloadet. Ja, das macht ja nichts, ja. Da hinein. Auf den Temp-Call in XDS kopieren. Und jetzt geht zurück zum RStudio. Im User Erasmus, dieses musst du in diesen Ordner hineinkopieren, dann solltest du ungefähr sein. User Erasmus, Aquaphotomics, dort kommt der Temp-Call in XDS. In diesen, also, genau. Nein, nicht. In diesen Folder, dann musst du hin navigieren und dort ist X-Call in XDS dort hin. Genau.
That everybody exists a number of rows for the setting.r.
The source code is currently, I have different numbers.
I have almost 300 rows. He has 64. She has 100.
Really? That's fine.
Is that normal?
No, it's not normal. It's weird. It's
weird.
It depends on. No, it should be the same. It depends on your solution. Maybe it depends
so
on.
At the end, are we running the routine 2 part, or are we running the second part?
We are running routine 2. Routine 2 is the one that's routine 1 and 2 is the one we're counting. The different numbers.
It's the card window.
Well, it's
because this is.
Zoltan, here. Zoltan? Where is Zoltan? Here. That's fine.
So actually, what I first. So you are on the right track. So you did this, that's good. Okay,
Joe, could you do me a favor? Could you go around and help people a bit, please? That would be great. So,
you were a material master. You have that? Aquap2? Oh, yeah, go to the website.
Okay, now to the. This is good. Now you do that.
No, I don't see you download it.
First this one and then the next one. Let's do that. Okay, just do that. Okay, who needs something? We have issues here and there. Okay. Jetzt sind wir noch diese zwei Sachen da im RStudio. Schauen wir es dann an. Please, when it says you have to restart R, this is very important. You have to always read what it says and then do what it says, otherwise things will not work.
because it's not the same.
Well, the different numbers are very, very weird. I don't understand that.
I could put them in documents, so I avoid the trick for the next one.
It doesn't put it there.
You made a new working note.
You made a new one?
Yeah, I made this one because of the two projects in the document.
Where's the picture? Yeah. Yes, that has to be fun. What is it here?
I just went to here and then. So I shouldn't. Yeah, no, I shouldn't.
I don't.
That's strange. I opened it.
Yes, but you okay?
That's maybe.
The problem. Yeah. So the point is, we are all at very different parts of the program, parts of the thing that makes some problems because some are more ahead and then they are doing different. So the dev tool, the GitHub install for aquap2. Who has already done it? Who has successfully? Telling me, colleagues, wonderful. You too? Yep. Give me a second. Who has already successfully? People, please. Who has already successfully downloaded the aquap2 from the GitHub page? 1, 2, okay. Who is still working on that? Oh, 1 second, everyone. Who is still working on the GitHub install from aquap2? Other way around? Okay, you're still? Okay. It's good, Kurt, please handle it, yeah. This is very good. So now restart our, quit RStudio, stop it, quit it all. Just quit it. Close, yes. No, don't save. It doesn't matter. Server, some USB stick with your raw data, and now the big problem, how do I get it into the analysis pipeline? aquap2 can help you in data import and organization of the whole process. It can import spectral data, of course, and what it does as well, all the metadata, sprich all the data describing all the class and numerical variables you can easily import as well. We provide a consistent coloring so that the same element, the same class, always has the same color, if you want that. And there is a method to actually record the temperature and humidity at the time of the experiment and align this to your data and do funny things with that. And other things. So after data import that you can be helped with, you come to data analysis and visualization. What we saw before, what Ali introduced, is definitely easier because it's point and click. But of course you can automatize that as well. What you can do here is a big advantage. We have this a user-defined splitting of the data set. I hope we will come to this. So if you have repetitive tasks you want to apply on your data set, and you say, okay, I have, let's say, 20 subgroups in my data set, I want to have the same analysis on all of the 20 subgroups, you just say, please do that. And that's what it's doing.
Okay.
And yeah, like we have a new version of the aquagram, which is, in this case, it's an improved version of the aquagram the package is offering. And as we said, we have a highly flexible input and control system. So you have different levels of controls that you can apply to your specific situation. We will come to that. So the first part of all your experiments is you need a folder structure.
Yes. Yeah, I think first this slide briefly summarizes a general workflow, how you can use this aquap2 package in your analysis. And the main parts, without going to details, first, as just Bernhard mentioned, we need to have a setup. This is what we copied. Okay, so you already have this one for today's demo data, this structure. And then after, it will help you to design an experiment, and then it will support the data import, and then you can do the data analysis. So these are the steps what we would like to go through together with you. So please go to your folder, what you downloaded.
To the course material folder?
From the GitHub server, and you will find a blue icon called Start. Please start RStudio with this. So this is an RStudio project. We will work inside this RStudio project.
Your screen should now look like this. You should have, most of you, all the software successfully installed, and you open this RStudio project from within your course material folder. It should look, your screen should look like this now.
Do you have the same? Okay. Without going to details, so what we will do now, we will open code, what we will go through. It contains the instructions how to do the data analysis. So please, on the right bottom corner, there is a window, and there choose Files, and inside this window you will find R code. And inside R code, please open routine2.r.
Just by clicking on it.
Just by clicking on it. And what you will see is a pre-written script for the data we provided to do data analysis. Where you see hashtag, then this is comment. Okay, so this is not taken into account in the execution for the software. This is only for us. These are comments for us. You can go to the line 8 and execute this line by clicking on Run or Control Enter in Windows.
Or on Command Enter in the Mac. I would recommend the Control Enter or Command Enter. So you go to this line, put the cursor there, and just hit Command Enter, and this line gets executed. This means the library is just being loaded. And so with this course material folder, we already provided the folder structure because we don't have much time, as you realize. Now we have our folder structure. We have started R in this folder structure, which is good. And we now launch the library. Now, if you do an experiment, the first part in the workflow, we say it can help you design the experiment. Yeah? So we already built the structure. We provided that, just to be short. Now we make an experimental design. And just because we only want to give you a quick taste of what aquap2 really can do for you, we'll just now execute the command ESL, which is actually import sample list. Then you go to this line. What it all does, you can find it later on when you look at the help manual. We don't have time for this now. Just go there, hit Command Enter, and then what will have happened is it says it created a sample list for you, and it wrote it to file. Now, if you go in your Explorer or in your Finder, depending on the machine, you go into the sample list folder of your course material. You go to SL out. You will find suddenly a new, freshly appeared Excel file. If you open that, you will see, wow. According to some rules that you specified, what you will learn when you go into the whole material, the packages made. The package made a nice sample list for you. You now can take this file on your laptop, go to the lab, make your measurements, and work it one row after the row. It is randomized to try to avoid machine drift or any other complications throughout the day. Okay.
Yes, and right after you did the experiment, you can analyze your data within basically few seconds, not in details of course, but with this automated software. What you need to do only to copy the files into the correct folders. So what does it mean? You modify the sample list because probably you provide some more reference data like concentration of something, or you add additional variables, and then this file has to be copied to the sample list in folder as we did already for today, and then you copy your raw data containing the collected spectra, which can be in very different file formats, and you copy here your temperature logger data if you have one, and you are set. After this, the next step.
Of course, all these formats, the raw spectra and the temperature logger data, they can have many different forms. Some of them are already implemented, so you can just say, I have this or I have that. You can have text files, Excel files. You can make your complete custom import by plugging in a function for the pros who are interested in that. Just saying, we think this is a quite powerful method, quite powerful tool to import anything, any kind of data into aquap2. And we are now focusing on this specific example where we already provide the test data.
Right, and after this, the import is very easy. You just execute line 14 with this GFD function, of course providing the sample type and the name of the temperature logger, and then you should see a message like it's projected on the screen, importing data. This is a very complex function. It combines all of these files, what we have seen, and even detects outliers based on some rules, and then at the end this data is saved on your disk.
So to really make it clear, the nice thing of this is you have a set of raw data, many files with your spectra, and you have this Excel file that tells you exactly which describing the sample. What aquap2 now did for you, what we just watched, it actually fuses together, those two files. Additionally, fusing according to a timestamp, if you have your temperature data, so that in the end you have a block of data describing your data, having the temperature, some other things, plus of course the spectra. So who has succeeded in doing this so far? Some? Who has not succeeded in doing that? Okay, 1, 2.
Did you get any error message?
But you did. It went before.
What is the?
Okay, we talked about that. Okay, but for the majority, kind of it worked, we can say. Okay.
Yes, so with this single one function, this structure was built, and you can see a new file in your R data. So it is saved in your disk. Next time when you get back to this analysis, to this project, and run again this function, then it will say the data is loaded. This fusion is not necessary anymore because it is saved in your computer. So actually after this, we are already at this stage, we can start the data analysis. So this lot of time what we needed to take now is not required all the time. Once you are set this way, then you did your experiment, copy the files in the respective folders, you run this one single line, and you are there to analyze your data. So the lots of copy pasting, what probably happened in the past in Excel, to structure your data is not required anymore. And then you will see the data analysis will be also simple like that. Once you know what you want to analyze, then after just very few setup, you can do it very quickly.
Okay, I just really want to emphasize what Zoltan said. This is very important. All the importing and stuff, you only have to import it once, and then it is saved, and then you just load your aquap2 dataset and can play around with it. And this will be the majority of the time, of course.
So, for example, plotting of raw data is just as simple. As you can see in line 18, if you execute this line by pressing Ctrl R, Ctrl Enter, or Command Enter in Mac, then you will see plotting row spectra is happening. And after this, you can see the result in your result folder. So if you go to your results folder, you will see a new PDF file there. And if you open it, then you will see your row spectra based on some coloring rule was already plotted.
You might feel confused that you see, oh, I'm doing things and I don't even understand what I'm exactly doing. For those who really want to use it, every function that we lined out in the routine number 2 is I hope in great detail described in the help, in the manual of the package. So if you want to know all the options like TTL equals F, what does it mean? We don't have the time to explain all of this now. You will find this out all in the manual, in the manual of Aquap2 in our program.
Okay, so the data set we have now for this demo for today, for this course, is temperature data set. We acquired temperature of spectra of 3 types of waters at the temperatures displayed here, plus we measured air in between blank spectra. So let's continue with the data analysis. In the next step, what we will do is a simple PCA. For that, after necessary setup of the analysis procedure list, what we cannot explain now, it would take too long, you just need to launch this single line, as it is in 21, to generate a set of results. So we generate a new object in R called CU, and it contains the result of PCA. So after that, the only thing what you need to do is to plot the results. So plot PCA, and it will provide you the PCA results. So you will see 2 additional PDFs appeared in your results folder.
No, sorry.
So without going to details, probably not surprising, what we can see on the first page of the scores, PCA scores PDF, is a bunch of scores on the left side and some scores on the right side. Probably it's not surprising because we left the air inside the data set. So obviously more than 99% of the variation is this difference, describes the difference between waters and air. And you can see the loadings as well. So the next step of the data analysis should be to remove this air spectra from the data set.
Just another quick general thing that I want to tell you. If this is not like this line is not, you have to write exactly this line and then this will happen. So the purpose of all this code is just to give you an idea how things go, and then it is, if you really want to use it, if you want to go there, it is your task to really at home sit. This will take days, weeks, to really read it through. Okay, I was using the function called GDMM. Then you have to look it up. Okay, what does it do? And from this template, if you learn how to work the program, you can then find out how to analyze your data. So this is just an example we give you to give you a first hint and saying that it can work, it does run, it can do things, and you have to look at the code, study it, read the help manual, understand. If you really understand what is happening here, so my suggestion, first you understand exactly what is happening here. Once you do this, then you can use it for your own purposes.
Okay, so as I just mentioned, the next step, the next logical step is to kick out the air, the blank spectra, and you don't need to scroll through in Excel your entire data set. You just execute this line. SSC means subselect any class, and you provide from which class variable, which column, what type of data has to be removed. In this case, we called it air, and then if you run this, then you get a reduced data set. You will see the original data contained 333 observations, while the reduced one without the air spectra contains less. After this point, logical step to run Pca again with the same command gdmm, and then plot the results of Pca. So if you go back to your results folder, you will see again 2 new PDF files which contains the loading plot and the score plot of the Pca. Now we can see scores of air disappear, and instead we can see the scores of the waters colored by, in this case, the sample name, the water name. And of course, in the analysis procedure, you can list up all the different class variables you want to use for coloring. So in these first 2 pages, you can see the scores colored by the water type, then colored by temperature, then colored by consecutives or whatever you want. And what we told at the beginning, how to speed up the data analysis with this package. You might want to use different ranges, wavelength ranges. So this is a repeated task, right? Because you select one range, you do the analysis. Then you select another range, you do the analysis. It is much simpler here. You just list up in the analysis procedure list or in this code what ranges you want to use for analysis. You run the same code, and then you see 3 message came up with 3 subgroups of your data set. And then now we can, for example, look at the raw spectra zoomed in to this, for example, first, second, and third overtone of OH. So now in the results folder, a new PDF file appeared showing the third, second, and first overtone range of your data set. What we can see here, there is a baseline shift in the first and second overtone. So we might need to apply some pretreatment. We had great discussions today about pretreatments, so I will not go to details. Instead, I will just tell what we did in this course materials. We will apply SMV. So applying SMV again is very simple. You just provide an attribute of this function and define what kind of data pretreatment you want to apply, and you run again, and you got your PDF file in results. Again, only raw spectra, but after pretreatment. Okay, so after this, again, making a Pca is just that simple as we did before. And regression, if we want to do a regression, for example, on the temperatures, then again, we just say we want PLS, do PLS equal true, and also if we want aquagram, we set it true. So even you don't need run many lines. In one line, you can define what type of analysis you want to perform, and then it will go through. In this case, with the first overtone, using separate data sets for the individual waters, and then we did, in this case, PLSR and aquagram calculations for all these 3 set of spectra.
Okay, so a little bit more to the depth here. What we did now, we made a regression on water temperature within the subgroups of 3 different water types, and we made an aquagram. And to make the classic aquagram, just describing the
temperature.
Just describing the temperature within each of the individual groups.
So what you can see now, after executing these 2 lines, so doing the calculations and then plotting the results, there were that many PDF files generated in your results folder. And if we open some of them, or all of them, then first we can see the Pca graphs, and now observe, here we have only one sample type, one water type, and it contains 18 pages. So the repeated task was really performed, calculated. Here the first water Pca score plot colored by the different temperature step, and then here is for the second water, and then here is for the third water. So with one line we calculated Pca separately for all the three different type of waters, and of course we have the loadings as well for them. And at the same time,
one quick thing to say for the programming pros, for those who want to, of course it does produce pictures, but you always can access all the calculations numerically. For those who doubt it's just pictures, you always have calculation and plotting separated. You always can access all the numbers.
And then, as I told, with this one single line, we also calculated PLS regression. Not surprisingly, we got very good results for the temperature regression. First page shows for the distilled water, then the third page for the milky water, and the fifth page for the tap water. And again, with this one single line, we calculated aquagrams as well, separately for distilled water, milky water, and tap water, using the classical type of the aquagram calculation method. We have, as Bernhard mentioned, we have several different types coded of the aquagram calculation in this aquap2 package. The following lines will show you another type of aquagram calculation.
Maybe we should go to 13. We skip the classic diff.
Okay.
Go to the linear and that's it.
Again, yes, in this case, we will reduce our data set to emphasize the benefits of the new aquagram calculation method, because in this case we will calculate standard deviations and confidence intervals as well for the aquagrams. And for that we use bootstrapping, which might take for some time in your computer.
It basically is parallelized, but due to platform problems we switched it off for now, just for those who are interested.
Okay, and again, so the results are calculated, we need just to plot them. So once you are through in these three lines, then again you must see a new PDF file in the results folder which contains the graphs for this new type of aquagram, which already a linearized version of the previous one.
Go to the next one, next slide. Okay, so this I would say is something very important. That the importance of this I cannot underline enough. So this actually is an aquagram, but not in a circular way, but in a linear way, which has many advantages. And you see here the shaded stuff, you see here actually confidence intervals, because we implemented and went to this method to calculate the aquagram based on the temperature calibration curve. This was the file that you copied before. This is the temperature calibration. So we finally have an aquagram with a real fixed values that actually mean something, actually degrees Celsius. And in this aquagram we can see that this sample is around 32 degrees. We can actually see the impact of a difference in a value of degrees Celsius, just to describe it now like this. And we have confidence intervals. So if we have enough samples, we really can see at what WAMAC is something significantly different from the rest. If you go back one.
Yep.
So this is very important, and I really like to ask you to please study this, to please, if you want to use it, familiarize yourself with that. 1 minute left. I just would like to go to the follow structure once more. Our studio. So now you saw what can be done. You might not have understood what you really did probably, but please can we go to the folder structure of the course material. So all this, aquap2 is based, Kurt, please. Aquap2 is based on a few things. You have your file structure. In your file structure, please, when you study it, go look at the folder structure we provided. We have the metadata folder. Here, in this, there are living two files. In one file, you describe the metadata of the experiment, you will see. In the other one, if you open it, in the other one is the metadata. You have the analysis procedure, if you open that, for example. So we provide a script that tells you exactly what to do exactly in your analysis. This is extremely powerful, and that's what it makes it a bit complicated. So you can describe your experiment, you can script your analysis in this analysis procedure stuff here. If you go up again, please, Zoltan. And after that, of course, you have your data and code. We had that, your raw data, and your results come into this folder. This is what you always have to have in mind. After, when you analyze data, you saw two ways of dictating it what to do. You have this file, the analysis script, and you can override values what we did. So at home, if you study routine 1 and routine 2, you will find out what we meant by that.
Thank you very much.
So, thank you.
Very much. So, we don't have enough time to discuss, so please ask them during the symposium.
Yeah, so if you want, in any days later, if your installation didn't succeed and you want it and you have any questions, always come and ask us. We are very happy to help anytime except 3 o'clock in the morning, then we'd like to sleep. But otherwise, please ask us. Thank you very much. Thank you.
Thank you.